We're going to look at vaporization in a little bit of detail. So vaporization is anytime you have a liquid going to a gas, and there are really two different types of vaporization. There is evaporation and boiling. And so sometimes in here we'll go back and forth between calling it evaporation versus vaporization, but anyway, so if these molecules are liquid and they if one is moving fast enough in the right direction, it might escape. Well, what keeps them in place is that they are attracted to each other. But again, if they are moving around, and if one is moving fast enough, like its temperature is high enough, moving fast enough, it might get away from its neighbors, and then it would become a gas. Okay, so what it depends on is that this molecule having enough kinetic energy to escape. And when it leaves from the surface like this, this is called evaporation. Okay. Vaporization or evaporation, remember this is the more general term, can occur at any temperature, but it occurs faster at high or low temperatures. Because at higher temperatures there are going to be more molecules that have enough energy to escape the liquids. They have to get far enough away that that attraction doesn't take hold and pull them back in. And so we need to remember that at any given temperature, the molecules aren't all moving at the same speed. There is a distribution of kinetic energy. In other words, if you're at a low temperature, this is the curve of how many, the number of molecules with each amount of energy. So even if if you have some water that's cold and it's sitting out, some of the particles in there may have enough energy to escape. But the higher the temperature, you're going to have more and more that have enough energy to escape. Okay, if we close a container, and let's just start here, when you first close the container, there are no, we're going to pretend like we just put this liquid in here and we close the container, there are no gas particles up there from this liquid. Okay, but if you give it time, it starts to evaporate or vaporization, and at first that's all that's happening, is that this is vaporizing and it's starting to build up here. But the longer this goes on, the more gas particles you have, and the more you have in this closed container, the more likely it is that one's going to bounce and hit the surface. As soon as it hits the surface and gets in contact with its neighbors, it's going to become a liquid again. It's going to stay there. So eventually they will be leaving and coming back at the same rate. Not the same molecules, but eventually this will reach what we call equilibrium. Where vaporization and condensation are happening at the same rate. And I see the answers were on this slide already. So what I just said, when those rates are equal, it's called equilibrium. And you guys, we're going to see different kinds of equilibrium, but the whole idea is that opposing reactions, opposite things happening at the same rate. Notice that once we reach equilibrium, and these are coming and going at the same rate, the pressure of these gas particles of the gas up here does not change anymore. Initially it was going up until it reached equilibrium, and now the number of particles are the same all the time, and so the pressure is the same all the time. The liquid level will also not change because we don't have a net change in how many are in the liquid versus the gas form. The vapor pressure is the pressure of this gas at this point. if you have a gas at equilibrium with its liquid, the pressure of that gas is called the vapor pressure. This is why, you put lids on things. Because once you put a lid, like if you have some perfume or something and you put the lid on, that causes the vapor to build up so that it'll start to condense again. If you just left it open, it would just all leave. But by having that lid, it starts condensing again, and so you reach an equilibrium and you quit losing your perfume or cologne or whatever. Okay, so how does temperature affect vapor pressure? Well, if you have it warmer, you're going to end up with more particles in the gas phase. So, say it goes up. And that's not to say these are both at equilibrium. It's just that when it's warmer, you're going to make the gas phase more stable, and so you'll have more at equilibrium in that phase. Okay, so this is a chart showing how with you increasing temperature, vapor pressure goes up. And so that's what this curve is saying, vapor pressure goes up. So, so we got two curves for different compounds. To answer these questions, we need to think about the attractive forces. What kind of attractive forces does this compound have? It has dispersion attractions only because it's a hydrocarbon. So this compound is nonpolar. It has dispersion attractions only, which is pretty weak. This one we see has that OH there. So this one can form hydrogen bonds. Okay, so which do you think would evaporate more slowly? Well, these, basically what we just said with this, these are going to have stronger attractions between molecules because hydrogen bonds are much stronger attractions than dispersion. So which would evaporate more slowly would be the one that's more stuck together. Which would have a higher vapor pressure, that's going to be the ones that aren't stuck together so much. Okay, and if we see from this chart, if you choose a given temperature, the hydrocarbon will always have a higher vapor pressure than this is an alcohol.